It's my pleasure to introduce the second speaker of today's function, Mr. Mohan A, who is an alumni of our department as well as our institute, 1992 batch. Mr. Mohan has over 19 years of experience in petrochemical industry with a particular focus on instrumentation, DCS systems, and process control. He holds a BSc in chemistry from Madurai Kamaraj University, did between 1989 to 92, and a BTech in instrumentation engineering from Madras Institute of Technology, 92 to 95. Currently, Mr. Mohan serves as a senior staff engineer at Advanced Petrochemical Company in Al Jubail, Saudi Arabia, where he has been for the past 8 years. In this role, he leads a team specializing in instrumentation, DCS, and control systems. Prior to this, he held the position of section head for instrumentation and DCS at the same company, where he led a team of engineers and technicians. Before joining Advanced Petrochemicals, Mr. Mohan worked as a process control engineer at both Advanced Petrochemicals and Tasnee Petrochemicals, contributing significantly to projects involving the installation, commissioning, and optimization of control systems. He also led the factory acceptance test for DCS ESD systems at Honeywell, Korea, and played a key role in improving control system performance during operational upsets. Earlier in his career, Mr. Mohan was a control system engineer at Samsung Engineering, working on projects in Saudi Arabia and Egypt, and an instrumentation engineer at Indian Petrochemical Corporation, where he focused on DCS and ESD system maintenance and modifications. With a wealth of experience in large-scale petrochemical projects, technical coordination, and troubleshooting complex systems, Mr. Mohan has consistently demonstrated expertise and leadership in this field. Please join me in welcoming Mr. Mohan for this August gathering. So I'll give the floor to you, sir.
Thank you, Dr. S.RENGANATHAN, for the elevating introduction. Good afternoon, Dean MIT, Dr. K. Ravichandran, Head of the Department Instrumentation Engineering, Dr. Srinivasan, and fellow professors, and our Amita, President, our Senior Sendilnathan, and dear juniors. I'm very happy and elated to be part of this endowment lecture of in the name of Professor S. Renganathan. When I passed out MIT, he was our dean. At the time we used to call director of instrumentation in the electronics department. It's a separate, we had a position director, and later he became dean MIT. Thank you for this opportunity to interact with you. I'm so elated to deliver this presentation in front of you. Before we start the presentation, I just like to highlight a small incident happened when we were in final year. It's something related with the earlier presentation so Kodishwaran gave it earlier about the roles and different roles as an instrument engineer we play. One of our seniors from 40th batch, I belong to 44th batch, so he was working in Bombay. So when he went to his native place, he just dropped by MIT, and then probably you might be aware of Professor KVN. He was our placement officer. He brought him to our final year class, and then when he came, he is very enthusiastic, energetic person. He just straight went to the board and put +2, you pass, okay, go to IIT or NIT, premier institutes, and then get into a good job. if you could not do that at that time, okay, you have option, join a good science college and join MIT and then go to Gulf direct. So that's the motivation he gave. So similarly, now after MIT, either you join IPCL or Reliance. Those days, these were the two major petrochemical giants at that time. Later, Reliance took over IPCL. So I went the path that shown by our senior. So I joined core engineering. I went to IPCL. I spent 4 years and then moved abroad. So today it was heartening to see what are the roles, and as an instrument engineer you can play in the earlier presentation. Thank you, Senior Kodishwaran, for bringing up this wonderful subject to enlighten what are the different roles we play in this industry. This just the earlier discussion and the question about the roles just triggered my memories. So I thought it would be nice to share with you this information. Let us now move on to the topic for this presentation. Let me share the screen. I hope I'm audible, right? I started giving my speech without checking.
Yes, sir, audible. Audible.
Thanks. Yes, I'll share the screen now. You got it?
Yes, sir, visible,
Yeah.
sir. Please visible.
Yeah. So we will touch upon important trends which is coming up for the petrochemical industries, and then later we will discuss about the cyber security, which is also an emerging trend and need of the hour. So the first thing is digitalization and smart instrumentation. So one of the industry 4.0 is industrial Internet of Things, IoT. So now these are the things now, machine learning and artificial intelligence, big data analysis, all those things now they are coming as a product in the industry. So in the form of smart sensors. So we are using these products to enhance the reliability and the operational efficiency of the plant. When we do this with advanced analytic tools, we are able to predict the failures, which helps us minimizing the downtime. So this is one of the trend. And secondly, the digital twin. The digital twin is nothing but a replica or a physical world now modeled into a digital world. So that's called digital twins, so where we can simulate things before we implement in the plan for any management of change or any changes in the requiring as part of the operational requirements. We are using the digital twins model, and we use it before we verify them, the changes, the impacts, is there any safety impact or not, then we implement them in the real world. And there are some adaptive learning systems available nowadays. This is also now coming into reality as a product. So they learn from the historical data and they can predict whether we are operating the plant in the optimum efficiency or the peak efficiency, and are we able to control the plants in the window given so that we maximize our profit. So these are the major three trends on the digitalization and the smart instrumentation line. And then we have this wireless instrumentation. Even though it's not fully adapted in the petrochemical industry, considering the safety involved, So the safety and the control, we are still relying on the traditional way of connecting field instruments with hardware to the control systems. But to make our life more simpler, there are certain products where we can use these wireless devices as a portable ones whenever we have an issue going on plant or one particular pump having vibration issue. So instead of wiring a permanent solution there, we can put an wireless small clamp-on devices for monitoring vibration or any other particular measurement we want to do, and we can bring to DCS. So it reduces the cost of our installation, and it is giving us a continuous measurement instead of a rotating inspector going there and taking periodic readings. We have a continuous measurement, so asset monitoring is very close, and this gives us a better informed decision. So this is where our wireless instrumentations play a vital role in petrochemical industries. And then energy monitoring, this is nowadays across the globe, I believe. We should not waste energy. Here in the Saudi government, they have given the tight boundaries where per ton of product you are making, what is your energy consumption. So if we are violating that, there is a huge penalty. So every industry now is moving towards energy efficiency. So for that aspect, there are a lot of soft sensors coming into market. Especially, I can take one example, which is steam traps, because producing steam involves consumption of huge energy. So loss of steam through passing or leaking steam traps, it's a waste of money. So there are devices available which detects this malfunctioning, and then this is helping us in the energy saving and the cost. Also, we can take an example of inspection wherein our technology of drone is helping us. So like 100 meters, 130 meters flare stack. While plants are in operation, we cannot do any inspection. So we are having a scheduled outage. We want to inspect as a reliability improvements. Is there any failure? Whether I have to repair the flare tape or replace it or not. Earlier, we cannot plan. So we were doing a time-based maintenance. Every alternate turnarounds or every shutdown, just replace them. So it's involving huge cost. So nowadays, with the health technology improvements, with the high resolution cameras and drones, we are able to do inspection upfront, and then we can take an informed decision for maintenance. The other trend is remote monitoring control. Now at sites, petrochemical sites, there are some remote sites, or we don't have expertise in a single location. Probably they are sitting in the corporate or a multi-country facility where the units are connected, and expert sitting in one place is able to guide the site staff to take care of the maintenance and troubleshooting. So this is where the remote monitoring and report control is coming into picture. Now there are some products available. We call it smart goggles. So if a wearable devices, so in case of a major equipment failure, either the vendor, he can see what I'm seeing. If I wear the wearable goggle, as if he's in front of the equipment, and he can see and guide the people to fix the problems. So these are the developments, trends in the petrochemical industries now using. And then the major, one of the major aspects is the cybersecurity. So cybersecurity, earlier it was now considered not so important, but nowadays it is mandated by legally by every government. It's not just a standard, it's now become a legal requirement, because the consequences of cyber attack are severe. It's not just about money, it is involving people's lives. If a control system can be manipulated by the hacker, it can create havocs. So that's why cyber security has become mandated. So these are the top 20 cyber attacks in the control systems. So there are. This was published in 2020. How we can prevent these kind of attacks? Before we go into the prevention, this is another real life. It's available on the internet. Just in 2020-21, sees how many attacks, and these are all on major companies, not small companies. So this really brings us how we can do that. So we have in the control systems, like earlier presentation, we have the controllers, it's a PLC or a SCADA or a DCS. So if you can manipulate the set point of a process, for example, if you take a sulfur removal unit, sulfur has to be removed, but it has to be kept at a certain temperature so that sulfur flows out of the stream. If a hacker comes into the system and changes the set point or closes the valve for this temperature control, and the sulfur solidifies in the pipeline and is going to break down with probably a leakage, loss of containment, it's a safety hazard, that's also an environmental hazard. So if we need to prevent, in the screen on your right you see the controllers, how we can manipulate, we do that. How he is doing that? By using execution of the malicious ransom software or a malware, he introduces it. And how they come into the control system, either a corrupted USB, this is one of the major threats, or an email with a corrupted attachment. So how the email comes with phishing attack or identity theft. So these are so many other network. If you are connected to the outside world without any protection, so then they can come into your control system. So similar to the safety system, we have a layer of protection. Cyber security also we have a layer of protections. So the basic design of the controllers itself, embedded chips, we have the cyber security solutions available, and then you have the data protected by antivirus, hardening of the systems, whitelisting of the applications are there. Then on top of that, we have the domain group policies available, where you authenticate the users. Then you have the patch management systems, where time to time from Microsoft we really get the patches, security patches, we have to update it. Then you segment your network not all in one cluster. You segment them based on application usage or based on physical location. And then you have physical access control, like card readers or fingerprint, lock and key arrangements. And then on top of everything, the human is the weakest link. So awareness is to be given on cybersecurity, not only just people working in the control systems, also the whole employees in the company, because anyone can bring the malware or ransomware into the control system. In our company, periodically, almost every 2 weeks, every month, our IT, they are sending phishing emails, and by chance you click the link over there, then you are called in and given a cyber awareness refresher course. So we are putting all our efforts to ensure our business continuity and sustainability of this industry. So this is all the practices we are following in the industry. So as a control system guy, how I can make sure a control system is safe from cyber threats. So in your screen you can see the layer level 0 is the field instruments. Nowadays we have edge computing happening at the end devices. So now we are talking about sensor to cloud. So these are the layers we have it. So each layer we need to safeguard. How we can do that? So level 0 is the field instruments, and level 1 is our controllers, basic controllers, and the safety instrumental system, we call it SIS. Earlier we used to be known as ESD system, emergency shutdown systems. So the DCS is nothing but a basic process control system. So standards they call it BPCS. In common terminology we call it the DCS. And then on level 2 is the supervisory network, wherein operator stations and engineering stations are there. Data historization is taking place. That on level 3, then we have all the digitalization, smart instrumentation devices, or those nodes are there, wherein you take care of the asset management, asset performance management systems, wherein we have a digital communication, wherein you can get the diagnostics of the devices. The hardware systems, just 4 to 20 milliampere, it send you a signal of process parameters. The level is 0 to 100% in the vessel, or the temperature is whatever the range, say 0 to 400 degrees centigrade. So it's all coming at 4 to 20 milliampere. So there is not much information available for the control systems. But with the digitalization, there are heart-enabled devices wherein the diagnostic information and additional parameters can be transferred, and you can do a remote calibration for the devices. So these are called asset performance servers available, so through which we can manage the devices. So they are all in level 3. And then we cannot live in isolation, right? The older control systems are just alone. It stops there with level 3. But with the advent of big data and analytics, AI solutions, we need to have this information available at the corporate level so that they can do informed decisions and monitor the business performance continuously. So we need to have the connectivity, but not just directly. We need to have a secure way. So we have a DMZ with a firewall. And some companies, they go one extra step, they put data diode also. So whatever the information the level 4, the business level needs, they are all secured in the gathered by the data collectors, and the level 3 or level 2 send it to the DMZ node where the servers are there, or the archive servers. And from there, again via firewall, it goes to the level 4 where you have the enterprise-wise resource planning like SAP or PI from OSIS, or now it's Aviva. So those products are available. Using that, they can manage their business. So these are the different levels, we call it purview model, available to secure their plant. So in terms of hardware design, control system design, so this is in the EC 62443 design. We have different zones. We can divide the systems, like the basic process control systems, which is in yellow color, it's there as a one zone, and ESD system, which is SIS, that's on a separate zone. And nowadays the cybersecurity standards mandate that there is no connection between, direct connection between ESD and the DCS. So there is a special, you need to have a firewall if you want to connect these two devices between them. So different zones, they communicate through conduits. So these conduits are tightly tuned for enable communication between the zones only during special identified nodes only. Not every node can access the other node in other zone. So these are the conduits. And this is the another view of the same previous presentation, the level 0 process instrumentation, and in level 1 we have the controllers. Then level 2 operators are sitting there with their HMIs and operator stations. Then level 3 we have the historian workstations. So the patch management servers, antivirus servers, they are all they can get the managed security solutions from the control system vendor himself, because there are proprietary applications running in the control systems. So we cannot just take the patch released by Microsoft directly, and if you without verification, if you apply, you may jeopardize your own function. So instead of doing a safety, you may jeopardize the functioning. So we need to get it qualified by the system provider. This is what is the version of your application in your control system version, and then whether this safety patch released by Microsoft is compatible or not. So we receive this patch and then we deploy them. To have a streamlining for every industry to follow, this is a IEC 62423 model. So right from component manufacturer to system manufacturer and system integrators and the end users, they have well-defined standards available. So as a students, I'm sure when I was there, we had the ISA student chapter in MIT. I'm not sure if we have it now or not. So if you are there, well and good, all ISA members have the free access to view these standards. Of course, you cannot print, but you can view these standards and get it familiarized in these standards. It's going to be helpful to you during your campus interviews. And being a cybersecurity expert, it will be, it's an added advantage for you in the interviews, because here you don't need much experience in the field of instrumentation if you want to choose a cybersecurity path. Instrument engineers nowadays, there is no defined boundary. When you come in the industry, you are starting from field instruments until cyber solutions. So you are working as a network engineer, but for OT, the IT cybersecurity standards are separate, the requirements are separate. There, the primary concern is about confidentiality of your business data, but in OT, the primary focus is about availability and the reliability, the reliable functioning of the control system. So here we have a different focus, but the tools we use are more or less same. Probably it is little bit tuned for control systems. So as a fresh engineer coming out of college, if you already make yourself available with these standards, and there are certain courses available, even ISA themselves, they offer courses. So if you get it certified, it will be an plus for you. It's added advantage compared to others who did not go through this. So there is one standard, international standard is this IEEE 62443, and then we have a NIST standard, which is from the US. So the framework is same. We have 5 steps to identify. Unless you have the asset management, you have the list of assets in your company, your setup, what are the things, how many switches you have, what are the make, model, and what are the versions we have, what is the latest patch update. So this is asset management, we need to have it. And then governance is basically to meeting the legal requirements. So here, Saudi Arabian government, they adapted IEC 62443 as their country-wide standard. So we need to have an early audit every year. They come and audit our system. So you need to be familiar with the governance, which is the national standards. and you need to do a risk assessment by third party, employing them. They will come here, they will go through your systems, they will analyze the logs, setups, what changes you have made compared to last year, and what is the incident response. This is the next, and so all those things we need to have it. Then protect, what are the protection mechanism, we have it. Then in case of, in spite of all these two, if something goes wrong, the anomaly detection, this is where we have the VM, vulnerability management solutions, wherein known vulnerabilities are declared by all the manufacturer of control systems, and then we need to see whether it is applicable to our site or not. So we need to keep us, it's a continuous process. Cyber security is not, you buy the firewall, you buy the switches, put everything set up and then forget. It's not like that. It's a continuous process. And then in case of worst case scenario, in spite of all this protection and continuous monitoring, if something goes wrong, then incident response comes into picture, where you involve a team of, you invoke a cyber incident, then you get involved all the people, right from operations, IT, safety, and then we need to mitigate the threat either by isolating it or have a backup system over there, and then identify and see from where it is, this threat started, then how to isolate it, then you come back and fix it. For the recovery, we used to have backup solutions, and we have network backup systems. So we have Acronis, and we have scheduled it, and we do periodically. It's not enough just to do backup. You need to test it periodically, that the backup can be restored and bring the system back in service. So this is a broad overview as a cyber security for instrumentation in our control systems. We are using it. I hope I touch upon what is I'm doing basically. So I thought I will share with you through this endowment lecture. I'll leave the floor open now for the Q&A session.
Sir, thanks for your presentation. This is Srinivasan myself. And while you were talking about it, you said about that big data analysis as well as AI also. How far it is getting implemented on the industry side, sir? Especially on since you are working on petrochemical side, how is this AI is getting implemented, and as well as that big data where you can able to analyze it and you have come up with some solutions?
So currently we are using big data analytics in alarm management systems, where we have a flood of alarms, and then we need to manage them, so that we need to meet standards where for every 10 minutes we should have one alarm, but if there is a burst of alarms, we are using this big, analyzing it. There are products available, so where we are using big data analytics. Also the AI we are using in cyber threats. If there is a persistent threat happening, the patterns, we analyze the pattern from where it's coming, and then we go ahead of the hackers and we take action to prevent any unfortunate events. So that's the AI is used in cyber solutions. Try to understand the pattern, how it is the attacks are happening. So there are products available in AI for cyber, and then big data for plant optimization for the digital twins, the one I talked about earlier. There is big data is used.
Thank you, sir. Thanks a lot, sir.
I hope I clarified your query.
Yeah, yes, sir. Yes, sir.
Thank you. Thank you, sir, for this enlightening session. Your expertise and perspectives have truly added immense value to today's discourse. As all wonderful experiences must eventually come to a close, we now reach the conclusion of this memorable